these scores don't correspond to an exact number of questions answered correctly. As I said, it depends also on the level of difficulty of the questions you answered correctly or incorrectly. Okay? The score is directly related to a percentile ranking, which is a way to compare your performance in the exam, particularly in this section, compared to other candidates, to other test takers who took the GMAT in the last 3.5 years. Okay? So, for example, let's say that you get a 44 in the quantitative section. Your score is 44. What does it mean? That you did better than 54% of all test takers in the last 3.5 years. That's the meaning of this number here. Okay? What are good scores in the quantitative section? Well, it depends on the target score you want to achieve. Let's say that you want to get a 700 as your target score. You know, the max score in the GMAT is 800 points, but most people know that 700 or more than 700 are scores that many business schools consider appropriate, right? For candidates to be accepted into their programs. So the idea is, if you want to get a 700, possibly the scores that you need to aim at are these, starting from 48 points upwards. But if you are not aiming so high, especially, for example, if you are interested in attending a school in Europe, for example, or in Canada, they have score requirements that are less demanding. Sometimes schools in those regions demand a score of an average 650 points. If this is, for example, your target score, then you could consider other scores like these ones, 45 to 47. They are also acceptable to help you achieve these scores. So it all depends on the score you want to achieve. But if you are thinking seriously in getting a 700 plus, then I encourage you to focus your attention on these scores. Less than 48 probably wouldn't work for you unless your performance in the verbal section is outstanding. That is also possible. But later on, we will discuss how to assess your own performance for the exam when you practice, and to see what is your strength and your weakness, considering the quantitative and the verbal section all together, okay? For the time being, we will focus on talking about the type of questions that you will see in the quantitative section. We have two question types, problem solving and data sufficiency. Hola, ¿qué tal? Bienvenida. All right, so we said sí, podemos escucharte. Como ya estamos en clase, te sugiero que pongas tu micrófono en mudo para poder todos escuchar sin ninguna interrupción. Gracias. All right, people, let's continue. The first format is problem solving. As the name says...
Perdón, espérame.
As the name says, this format stands for problems, right? It has a problem, a math problem, and it provides you with 5 alternatives. You have to pick one, and that's it. That is problem solving. Typical multiple choice problem that is computer based, right? Of course, most of the questions in the GMAT are problem solving type. That is between 14 and 17 questions. That is slightly more than half the questions in the GMAT are of the first type. The second type is called data sufficiency. You have fewer questions here. This is a special format that we will discuss, okay, the rest of this session. The data sufficiency format is very interesting. Besides the content based on math, on some math topics that is concerned with arithmetic, algebra, or geometry, you will necessarily deal with some special features the format data sufficiency has, because the logic of this type of question is very special. Unless you grasp the logic of data sufficiency problems correctly, you will have trouble answering even the easiest math questions. So we will talk about this in depth as of today, actually in the following minutes. Talking about the contents that you will see in the quantitative section, you have arithmetic, algebra, and geometry. The level of arithmetic, algebra, and geometry you will see just correspond to high school math, okay? They are not very deep concepts. They are simple concepts that any high school student in the US, for example, takes at school. There is no calculus, there are no derivatives, there is no trigonometry in the GMAT, okay? It is true that among the arithmetic topics, we will touch some basic statistical concepts, okay? But they are not that hard that you can compare with a university level course. Nothing like that. Very simple concepts, actually. But indeed, what is the difficulty in the quantitative section? Most of the topics deal with properties and formulas that you are compelled to learn and memorize. Since you will take this exam unaided, you cannot get any help but what you have in your memory, in your brain, and your practice experience with these topics. And besides, there is no calculator for the quantitative section of the GMAT. So you will have to rely on manual calculations, right? Or mental calculations. So that's why it's very important to memorize a number of concepts that are critical to solve faster most of the questions in this section. Now, people, let's move on to talking about the data sufficiency question format. The data sufficiency question format consists of a question, basically something we have to solve. No? It's interesting that the two types of questions that you have in the GMAT correspond to what, when, how much, or how many. Typical questions that demand a value as an answer, a numeric value, okay? You need to provide a value. But there is another type of question that you can find in data sufficiency. It is the yes-no question, okay? Yes-no questions are questions that usually start with is, are, do, did, etc. Right? So you have these two types of questions. Then after the question, there are two statements. Two statements are two affirmations containing data, right? That you are supposed to evaluate one by one to see if using the information provided in those statements is possible to answer the question in a unique manner. Based on that evaluation you make of the two statements and the information they contain, you have 5 answer choices, like these ones below. Okay? The first one says statement 1 alone is sufficient, but statement 2 alone is not sufficient. Take this for example. Take this simple question. What is the value of x? If this is the question, statement 1 could be x minus 2 equals 5. Statement 2 says x minus 2 squared equals 25. Okay, so if those were the question and the two statements, how would we evaluate this? Okay, there is a logic to follow in the evaluation of this question structure. What we do first is check if in the text of the question there is any relevant or useful information we can make use of. Actually, here there is only question, so nothing else but a question. So we go directly to the statement 1. We read the statement, it says x minus 2 equals 5. From this, we learn that the value of x should be what? Anyone?
7.
7, thank you. There is only one possibility. All right. Yes, most of you correctly realized that there is only one value that makes this statement true, because 7 minus 2 equals 5. Okay? Because we can answer the question of the problem with the single value 7, we label this statement as sufficient. It is no time to choose an answer choice, not yet. Just label for the time being that the first statement you consider sufficient and move on to the second statement. The second statement says something similar actually. It says x minus 2 up to 2 equals 25. So from this, we know something, that it is possible that x minus 2 actually is 5 or negative 5. And that provides two possible values for x. X could be 7 or x could be negative 3. right? So you see there are two values this time. The first value is 7, and the other possible value for x is -3. If you don't remember very well how to solve this expression, which is called a quadratic equation, don't worry, because we will come to that at a later time. But for the time being, just know that statement 2 affirms that x could be 7 or -3. Since we have two possible answers to the question, that is what the GMAT, creators consider not sufficient. We should label this statement as not sufficient. Why not sufficient? Because it doesn't allow sufficient information to answer the question uniquely with only a single value, okay? Because of that, we label it not sufficient. Now we are ready to make a choice. We read the statements, we evaluate, and we go through the answer choices. Answer choice A or 1, they always appear in this order. This is the interesting part. Statement 1 alone is sufficient, but the statement 2 alone is not sufficient. This is exactly what happened in this question. So we will be compelled to mark the first option for an answer. Okay? Do you have any questions?
No, good.
Okay, good. What
Sorry,
would happen?
So the data sufficiency questions are all the same structure?
Yeah, this structure is basically the same for all data sufficiency questions. Okay? We will see a few more examples. What will happen if the order of the statements were first x minus 2 up to 2 equal 25 and the second x minus 2 equals 5? Well, obviously, the first statement then would be not sufficient and the second would be sufficient. If that is the case, the answer choice would be B, which says statement 2 alone is sufficient, but statement 1 alone is not sufficient. How is that you can get the option C, or the third option for an answer? Both statements together are sufficient, but neither statement alone is sufficient. Let's see another example. For the sake of clarity, I will use another color here. Okay, let's imagine that the text of the question is this: if x is a positive integer, what is the value of x? Same question, similar to the first example, so that we have now extra information before the actual question. Statement 1, we have x is less than 1. Statement 2, x is greater than -1. Isn't it true that if we evaluate these statements, we have to consider the restriction posed by the first part of the question? They are making a fact that x is a positive integer. Don't be fooled by the fact that there is an if here, okay? This doesn't mean that x being a positive integer is a possibility. It's a fact. You should take it at face value, because x is a positive integer for the rest of this problem. So you are compelled to put together the information in this part together with the information in any of the statements you are evaluating at a time. So when I read statement number 1, in order to check if this statement is sufficient or not to answer the question in a unique way, I say x is a positive integer less than 1, or actually less than 1, yes. As you know, integers are numbers that don't have decimals, right? So what are possible values of x? Well, can anyone tell? What are possible values of x if we consider that x is a positive integer? Oh, sorry, let's remove this restriction here. Otherwise, it will make no sense. Just an integer, okay? An integer. X is an integer, and we have that x is less than 1. Possible values of x. Anyone? Could x, for example, be 0? Is 0 an integer? Yes, that's it. Thank you, Maria Pia. Other possible values that x could take, what would they be? Can anyone tell any other? What other integers are there that are less than 1? Remember that integers are numbers that can have a positive or negative sign, right? Well, we will come to study integers in depth, believe me. Lesson 2, it's all about integers properties. But for the time being, let's say that, for example, x might be -1, -2, etc. There are actually an indefinite number of values that x could take. Of course, that makes the statement not sufficient because we have not just one possible answer to the question, what is the value of x, but many. What happens with the statement 2? It is a similar situation. If you check the fact that x is greater than -1, you know, on a number line, here is 0, here is -1, here is 1, 2, 3. So a number greater than -1 could be 0, 1, 2, 3. So we see that there is no single answer again. So that's why statement 2 is not sufficient either. What happens next? Since each of the statements is not considered sufficient, then we have to do something different in relation to the question 1 or these examples to the left. What we do now is try and see what happens when we put together statements 1 and 2. What happens if we combine the information in the two statements? We have an integer number, x, that is less than 1, and at the same time is greater than -1. Do you know any integer that complies with these two conditions? What would that be? Yes. Thank you, Melanie. 0. That is the only possible value, right, Maria Pia, that X could take. Since now we can answer to the question with this unique value for variable X, then we label the two statements together as sufficient, though neither statement alone or by itself is sufficient. So we are now in the situation described by option C. So here our answer is C. Both statements together are sufficient, but neither statement alone is sufficient. Of course, option D happens when each statement by itself is sufficient. This is possible. And how do you get to alternative E? Statements 1 and 2 together are not sufficient. Okay, imagine that for a moment you remove this condition from this question. What happens if we remove this? Then you know our analysis of the statements is not limited to integers alone. When in the GMAT you deal with variables and numbers, you have to consider that the universe or the universal domain for numbers, for variables in the GMAT is what we call real numbers. And what real numbers include? Real numbers include integers, that means positive integers, negative integers, the zero, but it also includes fractions, decimals, etc. Those are real numbers. So if they don't tell you that a variable is integer, for example, and they don't tell you anything else in the problem, you have to assume that it could be a real number. Any real number subject to the restrictions posed in the statements. So now, if we analyze this question in green color without the initial restriction, of course, non-statement is sufficient. But when we put together the two of them, we would have this. X is a real number between 1 and -1. And the real numbers between these two numbers, -1 and 1, are actually infinite. For example, X could be a number like 0, but X could also be -0.2, could be 0.8, etc., etc. So you don't have a single value now. You have many possible real values for X. In this case, together, they are not sufficient. I mean statements 2 and 1. And when this situation happens, then you mark option E. So this would happen if this question to the right didn't actually include the restriction that X is an integer. Okay, so in order to summarize the logic of this data sufficiency structure, I want to show you a diagram, okay, that reminds you of every step necessary to deal with this type of question. Let's move on to this diagram here. Let's identify some terms here, okay? What do I mean in this diagram with statement this or ST0? This means statement 0. Is there a statement 0 in the data sufficiency structure? Well, sometimes. Statement 0 means something like this. If X is an integer, any information prior to the actual question is considered a statement 0. Usually, that information is marked by the word if. And when you find this kind of expression before the question, That is your statement 0. That is information that you are compelled to consider when you analyze each statement. So the statements are 1 and 2, right? And they are always numbered 1 and 2. So here, to abbreviate, ST1 stands for statement 1, sorry. And ST2 stands for statement 2. Okay? So that's it. So what is your first step to approach data sufficiency questions? First, read the question, of course. You need to read the paragraph or the text of the question really carefully. You need to notice, if any, the statement 0. Spot the statement 0 and take note of it, because it's very important. Immediately, you need to proceed to analyze and evaluate the statement 1. But if there is a statement 0, you need to combine that information with statement 1. What you do is check whether the statement 1 is sufficient or not. Sufficient meaning that you are able to answer the question of the problem with a unique value. Okay? Let's say that you find statement 1 sufficient. What should you do? Well, we are here. In the output of this decision flow. We proceed now to the second step. We check statement 2 and evaluate whether that statement alone is sufficient. Remember, if there was a statement 0 in the question, consider the statement 0 at the same time you consider statement 2. You need to combine the information of both pieces. If there is no statement 0, okay, just stick to statement 2. From your analysis, you will have one of two possible answers. The statement 2 is sufficient in your opinion or not. What happens if you consider the statement 2 also sufficient, same as the statement 1? Well, then your answer choice should be D. Remember, this answer choice states that each statement alone is sufficient. Okay? So it's a good idea to remember that the option 4 or option D actually means that each statement alone is sufficient. So that's how you get to answer choice number 4. But what would happen if when you analyze statement 2, you consider statement 2 not sufficient? Well, if that's the case, this happening after you consider statement 1 alone sufficient, then you are compelled to mark option A. Remember, option A says exactly what is happening here, that statement 1 alone is sufficient, but statement 2 alone is not sufficient. Remember? Here. So that's how you get to either option A or 1 or option B or 4. Whenever you evaluate the first statement and that statement works for you, that statement is sufficient, then your possible answer choices can only be A or D. No other could be the correct answer choice, unless you are wrong in your evaluation of statement 1, of course. So what happens if, on the contrary, you consider that statement 1 is not sufficient? Of course, that is also another possibility. If statement 1 is not sufficient, what you do is just label statement 1, do some marking in the booklet that you will receive to do your work in the exam, and just label statement 1 as not sufficient. What could you do here? For example, if statement 2 or 1 is not sufficient, immediately discard these two answer choices. Okay? That's when statement 1 is not sufficient. What should you do next? Well, evaluate statement 2. Same as in the other case. No matter what you evaluate statement 1, you need to evaluate statement 2 alone or combine with the statement 0 if there was any. Then you need to do the same evaluation and judge. If you consider statement 2 sufficient after statement 1 seemed not sufficient to you, then your answer choice must be B, which says actually statement 1 alone is not sufficient, but statement 2 alone is sufficient. Remember? Here. So these two are like reciprocals, right? A and B. You would be here. Okay, if that happens to you, that statement 1 seems sufficient, but seems not sufficient, and statement 2 seems sufficient. Of course, there is always the possibility that when you evaluate statement 2 alone on its own, you consider that it's not sufficient. So what happens next? Well, what we did in one of the examples, we need now to label statement 2 as we labeled statement 1, and now we discard option B in this example. And then what should we do? Now we need to come to a special step in this analysis. In this special step, you will combine the information in statements 1 and 2 together. Of course, if there was any statement 0, remember the if prior to the question? Yes, you need to combine that information as well, together with statement 1 and statement 2. What's the purpose of this? Well, to see if the two statements supplement each other. Okay, if they provide enough information together so that we can answer in a unique way to the question. There's two possibilities actually, that they together supplement each other and you get a unique answer, or that unique answer doesn't actually happen. So if together you get a unique answer, you mark option C. If together you don't get a unique answer, then you mark option E. So notice the two answer choices that result, from this evaluation are these two. Both statements together are sufficient, but neither statement alone is sufficient. That's what states the third answer choice. Of course, that implies that previously you have evaluated statements 1 and 2 on their own, each one of them. But if together it is not sufficient to answer the question in a unique way, then you have to mark option E. Statements 1 and 2 together are not sufficient. Okay? So that's the meaning of each of the 5 answer choices in the data sufficiency question format. Notice that from this flowchart, you can see that the way to arrive at any of the 5 answer choices here is unique. There is a unique logical path that takes you to each of these answer choices. There is no ambiguity possible. Okay? ¿Por qué? Why? This is simply because you do this step here only when the statements 1 or 2 are not sufficient independently. You never combine the statements if one of them is sufficient on their own. Okay? Some people ask me sometimes, Gustavo, what happens if statement 1 is sufficient and statement 2 is sufficient? Do I need to put them together to see what happens? And the answer is no. You don't need to do that. When you finish evaluating the two statements and any of them turn to be sufficient, you have three possibilities actually. You have A, D, or B. So you can never evaluate them together if any of them or the two of them are sufficient. You can only put them together when the two of them are not sufficient independently. Is that clear? So now I want you to consider any questions that you may have for this part. I know this is a little abstract and probably it's not very intuitive at the very beginning. We will see with examples how to use this logic to analyze data sufficiency questions. Okay? Following, there is a set of examples that are original examples from the GMAT exam. That is to say, the questions we're about to see have come in previous exams in the GMAT. They are real questions from the exam. For the sake of clarity and understanding, we have selected a number of exercises that don't deal with very complex mathematics, with the most simple concepts of math, so that you can focus on the logic of the problem and not on the math concepts, which eventually you will master by doing diligent practice. All right? So let's focus on the next example. Here, question 1. Take a look at the text of this question. It's very simple, very short. It's X positive. This is what we call a yes-no question, right? Another thing we can notice from this question text is no statement 0. Take a look. There is just a question and nothing else. Okay, let's take a look now at the two statements. It says X is the square of an integer. What does it mean, the square of an integer? Well, if we put this in simple terms, that is telling you that X is a number resulting from multiplying a certain integer by itself. That is an integer up to the second power. Okay? 2 as an exponent of an integer. And the result of that, that means the power is X. X is an integer up to 2, or the same to say integer times the same integer. Okay? And an integer, as we said before, is a number that has no decimal parts. So that is the first statement. What do you say, people? Is this statement sufficient or not to answer the question in a unique way? No. Melanie says no. Does anyone else agree with Melanie? Maria Pia agrees with Melanie. All right, no. Anyone that thinks statement 1 alone is sufficient? Or everybody agrees with? Okay, Kathy, please tell us why you think statement 1 is sufficient. You can write it on the chat, or you can say it aloud, no problem. Okay, thank you, Kathy. You say that the square will always be positive. The square of a number, in this case of an integer, will be positive. So probably you are thinking that x could be the square of 5, for example. That would be 25, which is a positive number, right? It means that we can answer yes to this question. And in this other situation in which x is the square of a negative number, for example, negative 7 up to 2 equals 49, because that is the product minus 7 times minus 7, which is also a positive number. So we can answer yes to the question. So Kathy believes that because of this, no matter you raise an integer up to 2, you will always get a positive value. So the answer will always be yes. But now, why, for example, Maria Pia thinks that the statement 1 is not sufficient? Could you please tell us, Maria Pia, why you think statement 1 is not sufficient? You can comment on that via the chat, or you can say it aloud. Because it doesn't have a unique response. As we are seeing here that the answer is yes in 2 cases we tried with these 2 different values. When do you think we can answer no, Maria Pia? In which case could we answer no to the question, is x positive, thus changing the answer to the question? When it's negative, but you can see, even if we try a negative integer and we square it, that means we raise it to the exponent 2, we will always get a positive value. And the question is about the sign of x, not of this integer. Okay? We want to validate if the sign of x is always positive or not. Aha. Okay, Maria Pia, you are quitting your former standing on this. Carlos, you also think it is sufficient. But people, I believe Kathy signaled that this was not sufficient, right? Oh, sorry, yes, not sufficient. Actually, she was right. Why? Even though it looks like anytime we square an integer, we will get a positive number as a result, there is one special case that it usually, goes unnoticed. What happens when x becomes, yes, Kathy, very good, when x becomes the square of number 0? When you have 0 up to 2, that means 0 times 0, and that gives 0 as a result. So people, answer please. Is 0 positive? Yes or no? What do you remember from your school days? Maria Pia thinks 0 is positive. I'm afraid I have to dispute that, Maria Pia. Yes, Brian, you are right. 0 is neither positive nor negative. 0 is 0, and it has no sign. Yes, Fiorella, you are right. 0 doesn't have a sign. And because of that, the answer to the question, when we consider that x could be the square of integer 0, would be no, because 0 is not positive. Now, notice, we have a zillion cases where we might answer yes to the question. With any other integer than 0 squared, the result would be a positive number, and we can answer yes, but only with 0 as the integer that is being squared here, we would get a no for an answer. And just because of one no versus a zillion yeses, we need to say that statement 1 is not sufficient. So notice here how powerful the concept of data sufficiency is. Sufficiency means that you are always able to respond in the same way. In yes-no questions, that means that you should always be able to answer yes or answer no, but not sometimes yes and sometimes no. That would be a problem. That would be insufficiency, okay, according to the creators of the GMAT exam. Okay, we don't stop there. We need to continue with the analysis of statement 2. So now consider this. X plus 1 is positive. Think about this. Think of this statement in terms of the following. What values might x as a variable have so that x plus 1 is positive, so that statement 2 is true? What possible values of x could you think of? I'm listening. Which value of x could we use here so that x plus 1 is positive? Could it be 1? Yes, right? Because 1 plus 1 is positive. It's 2 actually. What other values of x could we try or could we think of? Now this is thinking time for you. What do you say, people? A negative number? Oh, for example, Melanie, which negative number could that be? -5. Let's check, okay? -5 would result in -5 plus 1 being -4. But you see, this result is not positive. So this value is actually unusable. We cannot consider that x could be -5 because the sum of -5 and 1 is not a positive number. In this statement, we have to take it, you know, as a positive and a true affirmation. In other words, the statement conditions the values that x can take. So, could it be 0? What happens if x is 0, for example? That means 0 plus 1 is a positive number. And yes, so notice that when we answer the question considering x with the value of 1, the answer to the question would be yes. But when we consider to answer the question, this question, with the value of x equals 0, then the answer would be no. And again, we have the same situation. We have two positive or two possible answers to the question. That is the concept of non-sufficiency. All right? So take a look, something interesting. This is a little twisted. We cannot try values of x that deny or contradict the statement. We can only take values that make the statement true. This is something important. Another thing, we need to consider different cases when we try values that can help us distinguish the case of not sufficiency. Okay, in this case, achieving two different answers with different allowed values of x means to have not sufficient for the statement 2. Statement 1 not sufficient, statement 2 not sufficient. So what is left to do? What shall we do now? Do you remember the flow chart before? Let's take a quick look. What do we do when statement 1 alone is not sufficient and statement 2 alone is not sufficient? Somebody? Combine. Very good, Maria. That's true. We need to combine. So that we do. Let's combine 1 and 2. So what is x? Is the square of an integer that added with 1 is positive. So if we are thinking of possible values of x so that x plus 1 is positive, but at the same time x needs to be the square of an integer, well, we could have x0, right? This is 0 up to 2 plus 1, that gives 1, makes the statement true, but the answer to the question with x0 is no. And we could have, for example, x equals 2 up to 2. That means the square of 2 plus 1, that gives 5, which is making the statement true. But with this value of x, that means 4, the answer to the question is yes. Again, the same situation, not sufficient. Okay, but notice that should have been obvious from the very beginning. That should have been entirely foreseeable. Why? Because we noticed that in the first statement, you had one value for the variable, that is 0, that changed the answer to the question. In the statement 2, the same value, 0, changed the answer to the question as well. So whenever you notice that one statement is not sufficient and the other statement not sufficient, but that happening because the same value for the variable changes the answer in the two statements, then you don't need to waste more time. Directly, you can mark option E for an answer. Why? Because the presence or the existence of a common value that changes the answer to the question in two statements at the same time means that combining the statements, you won't get it differently. The same common value, that is 0, will make the two statements also be insufficient. So don't waste your time. Whenever you see that the same value changes the answer to the question, just forget about it and mark option E directly. In that way, you save a little time, skipping the step of combining the two statements together. All right? Let's move on to another example. Now this is quite similar, but there is a difference. Take a look. Before the question, there is what we called statement 0. There are some preconditions that you should assume true for this question and combine that information when you do the analysis of statement 1 and 2 on their own. All right, people, now it's up to you. I want you to do the analysis on your own for statement 1, then for statement 2. If necessary, you can combine them, I don't know. But then you tell me your answer. I'm gonna give you 2 minutes, okay? Let's make it real. In the exam, you will have just 2 minutes per question. So you have 2 minutes to get to an answer. Time's running. All right, some people are already posting some answers. Thank you for being so quick. But you can reconsider your answer if you want, right? Obviously, the expression non-zero just means that x is a number different from 0, right? Okay, that's a non-zero number, just in case. People, that is 2 minutes. You know, it's really fast. So tell me your comments on this question. What do you think? What are your answers? Okay, Melanie is posing E as an answer. Okay, let's see. A, B, C, D, and E. I believe Maria says D. Melanie says E. Any other answers here? Does anyone consider any other possible answers? All right, so let's see, okay? What do we have in statement 1? Now we have that x is a non-zero number that is the square of an integer. So that is to say, x could be the square of 5, which is positive. X could be the square of -2, which is also positive. And there are no more cases. Actually,
Sorry, I have a question.
Yes, please.
In the other exercise, you said that we cannot consider a negative number because the statement says it is positive.
The statement, you mean here, we couldn't consider the value of -5 because the statement affirms that x plus 1 has to be positive. And if you consider -5 here, the result wouldn't be a positive sum. It would just be -4, right?
Okay.
I said it because of that. Okay, let's consider here what happens when we think of it. X cannot be 0, so there is no possibility. Thank you, Brian. You also join the ranks of those voting for E as an answer. Now, if x cannot be 0, that means x cannot be the square of integer 0. That case is impossible, simply because statement 0 rules out that possibility. Thank you, Daniel. Okay, I will note down your answer here. Okay, because of that, there is no possibility to get a different answer to the question. It will always be yes. X as the square of a positive or negative integer can only be positive because a square is always positive when the integer is positive or negative. Of course, if the integer were 0, then x would be 0. But here it says that x cannot take that value. So we will leave the statement 0. That is what I meant combining the statement 0 together with the statement 1. Statement 0 here acts as a restriction to statement 1. In that sense, this means sufficiency. Statement 1 is positively sufficient. Now, statement 2. It says that x plus 1 is positive. Does it mean we can try 0 as a possible value? No, 0 we cannot try anymore because x cannot be 0. Statement 0 says that clearly. So what other values can we try? X could be 1, and then 1 plus 1, you know, it's 2. So here the answer to the question with this value is yes, 1 is positive. What about other values greater than 1? For example, 5. 5 plus 1 equals 6. Yes, again, these values make the statement true and at the same time allow us to answer yes to the question. Probably those people who consider D as a correct option thought that this guaranteed the statement 2 was sufficient. But think about it. What they say about x in the statement 0 is just that x cannot be 0. Does it say here what type of number x can be? It doesn't say, right? It only says non-zero number. It doesn't say it's an integer. If you are thinking, but teacher, in statement 1, it says that x is an integer. That is actually true. But that is only for statement 1. This restriction here doesn't apply to statement 2 at all. Why? Because that's the way the creators of this format designed this question format. The x in statement 1 doesn't even need to have the same values as the x in statement 2. You can look at this as if you had two different variables with the same name. The variable in statement 1 is a totally different thing than the variable, different from the variable in statement 2. They're different. In the second statement, x is a real number. That's to say, x can be a decimal, can be a fraction. In statement 1, x is only an integer. So, what values are possible for x that change the answer to this question? Now, take a look. Saying that x plus 1 is positive is equivalent to say that x is greater than negative 1. If you try and visualize that on a number line, it means that x could have all of these values. It is true that it can have values as 1 and 2, but it may also have values as negative 0.5, which is greater than negative 1. If you actually plug in this value to try the statement and say negative 0.5 plus 1 is 0.5, positive, right? This is a positive number, but this allows us to answer no to the question because negative 0.5 is not positive. And because of that, actually here you can count infinite values, right? Infinite negative values between negative 1 and 0 because they are real numbers, they are decimals. Okay, so because of that, the statement 2 has to be not sufficient because we have a change in the answer. But now, when we have a statement 1 sufficient alone and a statement 2 not sufficient alone, then we have a clear answer choice. And that was, oh, well, Maria Pia, actually, if we consider the diagram, take a look, this flow chart, when 1 was sufficient and 2 not sufficient, the answer choice is A, which is this, statement 1 alone sufficient, but statement 2 alone not sufficient. So here, we need to mark A. That is the correct answer. So Daniel was right. Congratulations, Daniel. You got it right. So people, that is the data sufficiency structure. Let's check just 2 more examples and finish for today. Question 3, is X positive? All right, so what does it mean? Is X positive? Okay, Kadi, you are leaving, no problem. Later on, if you will, you can access the recording of this lesson so that you can view it, especially for the tricky parts, right? Once over again and get a clearer understanding. So what about this one? Is X positive? They tell us that X is greater than -5, and in the statement 2, X is less than -1. What about the statement 1? Is it, oh, thank you, Maria. You say your answer for this is B. Okay, we know what that means. If a number is greater than -5, oh, sorry, yeah, I just took your previous answer. You didn't reply to this yet. Sorry about that. Okay, what about X greater than -5? Please, class, give me a number greater than -5. Or give me several numbers greater than -5. -4, perfect. Answer to the question with -4 would be no. Another, please. 1, very good. Answer with 1 would be yes, because 1 is positive. So that's it. There you go. -4.9, excellent. This is another no. But it is all right with just seeing that the answer has already changed. We don't need to try more values now that we see that we can have 2 possible answers, yes or no. That is not sufficient, okay? Because we can answer these questions in 2 ways. Sometimes we can say no, sometimes we can say yes. Okay, what about the statement 2? It says that X is less than -1. Can you please give me values for X? What possible values for X do we have? All right, -2, thank you, Maria. Any other? -20, Melanie, very good. Any more? No more, only 2? Come on, people, you can try. Any other value less than -1? So far, so good. With -2 as a value, we have no for an answer. With -20, we have no for an answer. -23.4 also yields no for an answer. So, what is going on? It looks like it doesn't matter how hard we try, we cannot find a number less than -1 that can yield a positive or affirmative answer to the question. Because every number less than -1 will always be negative, and that the universal answer to the question will be no. Do you notice that this is a unique answer? It is always no. It will always be no. So that is sufficiency. The second statement is sufficient to answer always no. And because of that, the correct answer is this, B. Okay? Finally, people, let's take a look at a very interesting example. Question 4. if x and y are integers, is y a multiple of 3? Sometimes when people take a look at questions with variables, they tend to make a common mistake. Look, here there is a statement 0, but the only thing it says is that the variables are integers. What do we have for statement 1? Y equals x times plus 1 times x plus 2. It's a product of 3 numbers. One might think, okay, this is a 2-variable equation. It has infinite numbers for x and y that make the equality true. So how could I ever say whether y is divisible by 3 or not? Because that's what a multiple of 3 means, that y can be divided by 3 and give an integer number. Some people say, no, it's impossible because there are infinite values. I have no way to tell if in every case y will be a multiple of 3. So they label it not sufficient. And notice what happens next. When they see 2, says x is a multiple of 3. But of course, there is no correlation between this information and y. There is no mention of y even in this statement. So because of that, it couldn't help us to answer the question. Okay, so most people are thinking about the same. Maria Pia, for example. She thinks that combining the two of them, we get to prove that one or that y is a multiple of 3. Because if x is divisible by 3 and I multiply a number that is divisible by 3 by other numbers, the product as a result would also be a multiple of 3. For example, let's say that x is 6. Then you will see that y equals 6 times 7 times 8. This will also be divisible by 3, right? It is equal to 3 multiplied by some integer, okay? Actually, it would be 3 multiplied by 2 times 7 times 8, right? Because 3 times 2 is 6. So we can clearly see that no matter that x is a multiple of 3, y containing x as a factor will also be a multiple of 3. And with that, people, they consider sufficient the two of them and mark C. But if you do that, you would be in big trouble because that answer choice is wrong. It's wrong. Why? Why is it wrong? Well, here this is a common trap in the GMAT. Sometimes you look at an expression and you don't see any relevancy. You don't see any sufficiency because you think that there are too many values for the variables, so that you can never tell or assess every case, every value for each variable and say whether or not the variable is divisible by 3 in all the cases. But sometimes you can try values before just labeling the statement as not sufficient. For example, you could do this. You could say, what happens when x equals 1? Then y would be 1 times 2 times 3. Notice that this number is divisible by 3. What happens if x equals 2? Y would be 2 times 3 times 4, right? Because this is what it says here. So that would be what? 24, which is also divisible by 3. And then you think, oh, but wait a moment, I'm considering only positive numbers. What happens if it is 0 because x is also an integer? Well, if you know some properties of the integers, then y would be 0 times 1 times 2, which equals 0. But 0 is divisible by any integer. So it's also divisible by 3 because 0 divided by 3 is 0. So no matter the number, even if you try a bigger number or a negative number probably, for example, you say x equals minus 5. Okay, then y would be negative 5 times negative 4 times negative 3. And this would be negative 60. is also divisible by 3. So no matter the case, it looks like we always get a multiple of 3. Then you can take a chance and say, okay, same pattern, always the same answer to the question, it is sufficient. Just in case you don't know enough theory to assess this statement. Why? Because there is an actual property that guarantees that y will always be a multiple of 3. And what is that property? Take a look. If you consider the multiples of 3 on a number line, such as 3, 6, 9, and 12, for example, you will notice that between them, between each pair of consecutive multiples of 3, there is always 2 other integers, between 0 and 3, between 3 and 6, etc. What happens if I take by chance just 3 consecutive numbers, which are these, right? X plus 1, and x plus 2 are 3 numbers together on the number line. If I take these 3, one of them is actually 3. It's divisible by 3. So if I multiply the 3 of them, I will always get a product that is divisible by 3. What happens, for example, if I take these 3, 5, 6, and 7? You see 6, another multiple of 3, is in the middle position. So if I multiply the 3 of them, I will always get a product that is divisible by 3. And what happens if I, for example, make another selection? I take this, starting from 9, 3 integers. You see, no matter the 3 consecutive integers that we choose on the number line, they will always contain one multiple of 3. No matter if it is the first, the middle, or the third position, but one of them will be a multiple of 3. So that the product y is a multiple of 3 is guaranteed by that fact. And we can extend this property beyond. We can say, if you pick n consecutive integers, okay, among n consecutive integers, there's one multiple of n. If you pick 5 numbers by chance, but 5 consecutive numbers on the number line, one of them has to be a multiple of 5. If you pick 11 consecutive numbers by chance, one of them has to be a multiple of 11. And that's a property. So sometimes when we don't know all properties, so that we can evaluate properly one statement, we can just pick values and try to see if there is a pattern, in the answer. So that is how we arrive at the correct answer choice. It is not sufficient, the first one. It is sufficient. Actually, the second is not sufficient because there is no mention of y. The correct answer choice here is A. Okay, it's not this. Okay, with that, people, we just finish the examples of this part. Okay, for the data sufficiency structure, you have always to follow this logic, just for you to remember. Okay, avoid these mistakes. Don't confuse the answer no with not sufficient. As we saw in one of the examples, sometimes the answer to the question can be negative. It doesn't always have to be affirmative. Don't forget that when you take the statements, these are true affirmations. You cannot try values that make the statements false. And you cannot also try values that just positive integer, for example. You have to consider that if there is no mention of the type of number you are dealing with, then you have to consider real numbers, such as decimals, negatives, fractions, etc. Okay? Be careful with those statements that look like they don't say anything. Like the example we just saw. Sometimes we need to plug in, insert some values to the variable, try to see what happens. Maybe the statement that looks like it's not sufficient, maybe it provides a single answer to the question all the times. And finally, be careful not to confuse the information of statement 2. Don't mingle the information in statement 2 with information in statement 1. At least don't do it until you have tried each statement separately. Okay? If you follow these suggestions and you consider these characteristics of the data sufficiency question format, you will improve step by step. At the beginning, you will find it a little hard, but don't worry, because every person that has trained for the GMAT has a hard time, you know, getting used to this format. So just practice, okay? Starting from the next class, we will give you homework, okay? The next class, we talk about fractions and decimals and also about powers and roots. This is the lesson for the next class. So you can download, you know, as I taught you how to do, you can download the first lesson so that you can take a look at the content, review the exercises if possible, and so you can prepare for every lesson. All right? Thank you very much. Sorry for we extended a little bit. This is our first session, but I think it was very important to, you know, try to get this straight to you. Data sufficiency is really important for your score chances, you know, in the GMAT. So you have to master this question type. Okay. Thank you again, and I wish you a very good rest this night. Okay. So see you on Thursday, which is our next session. I believe it's at the same time, probably at 9 o'clock, but you can also check the information that our academic department is providing you to work in this course. All right, people, everybody, thank you. Good luck. Bye-bye.